have now dealt with integrals with discontinuities in the lower bound and the upper bound. What we are going to be doing now is if we have a discontinuity in between. At the end of this lesson, you'll be able to evaluate an integral with an infinite discontinuity in between its lower and upper bound. Alright, so I'm going to actually jump right to the example and then we'll go up here and look at the notes if we need to. We would like to evaluate the integral from 0 to 3 of dx over x minus 1 to the 2/3. You'll notice 0 is fine because I could plug in 0 and get an answer. 3 is fine because I could plug in 3 and get an answer. However, if we plugged in 1, we would be discontinuous, and notice that 1 is in between 0 and 3. So that's where our trouble lies. And if we were to graph this, we would have an asymptote at 1, and then my function is going to look something like that. So I would like to find the integral or area under the curve from 0 to 3. But my problem is that I've got that discontinuity in the middle. So when we have a discontinuity in the middle, we're going to actually separate it at the discontinuity. So we're going to find the integral from 0 to 1 of dx over x minus 1 to the 2/3. And then we'll add it to the integral from 1 to 3 of dx over x minus 1 to the 2/3. Okay, now from here, when we're doing our discontinuity, this basically just turned into the first two problems in this video set. So what we are going to do is in the first one, we're not allowed to get to 1, but as I'm going from 0 to 1, I'll be approaching my discontinuity from the left. So I'm actually going to be finding the limit as, and I will call that w. W approaches 1 from the left of dx over x minus 1 to the 2/3, and then I'll add it to, on this one, if I'm going from 1 to 3, I'll be approaching the discontinuity from the right. So this will be my w. So I'll find the limit as w approaches 1 from the right of my integral. Whoops, I forgot to put this will go 0 to w, and this will go w to 3. And then dx over x minus 1 to the 2/3. So I now have two problems to work. Fortunately, they're both the same integral. When we do this, the easiest thing to do would be to do a u substitution. If u is x minus 1, then du would just be 1, which I have, 1 dx. And so then I'm going to rewrite this problem as it will be u to the negative 2/3. And so when I evaluate that integral, if I add 1 to my power, I'll get u to the 1/3. And then it will be 3. So this integral is now going to be 3 x minus 1 to the 1/3. And I'm going to evaluate it on this first one at 0 and w. So when I plug w in, I'm going to get 3 w minus 1 to the 1/3, and then minus, if I plug 0 in, 0 minus 1 is negative 1. Negative 1 to the 1/3 is negative 1 times 3 is negative 3. Okay, so that's what I get for that integral. Once I'm as far as I can go on the integral, we will find the limit as w approaches 1 from the left. And again, basically I'll be plugging in 1, and since I'm able to plug in 1, I'm not really concerned about it being from the left or the right. So if I plug in 1 to this, I will end up getting 0 to the 1/3, which is 0, times 3, which is 0. So I'll get 0 plus 3, which is 3. So that's what I get for that first part. Okay, when I go to do the second part, evaluating the integral, I'm going to get the same thing. I'll get 3 quantity x minus 1 to the 1/3. And then I'll be evaluating it at w and 3. So if I plug 3 in, we will get 3 times, plugging 3 in, I'll get 2 to the 1/3, and then minus 3 w minus 1 to the 1/3. Okay, and then that's as far as that problem can go. I can't combine those two because this one has a power on it and the 3 doesn't. And then from here, we'll be finding the limit as w approaches 1 from the right. And again, when we plug in 1, we don't really care about from the right because I'm actually able to plug something in and get an answer. When I do that again, 1 minus 1 will be 0. So this entire part is going to turn into 0. So for this second part, I'm just left with 3 times 2 to the 1/3. And we'll put a plus sign in between there. So basically that's my answer. I am going to rewrite that. There's a couple different things I could do. My answer is 3 plus 3 times 2 to the 1/3. There's two different things I could do if I wanted to. I could rewrite it as 3 plus 3 cube root of 2, or I could factor out of 3 and make it 1 plus either 2 to the 1/3 or the cube root of 2. So either one of those would be acceptable answers. So hopefully now you can evaluate an integral when we have a discontinuity in between the upper and lower bounds.